So question one, they are saying the atomic number of a given element is. So the best way to do this is to disqualify the answers, or to eliminate them rather. So the atomic number of a given element is. So what's the correct pick here, guys? What's the correct answer here? Yeah, so the correct answer here is number 2. We cannot even think about number 1, because 1 is the mass of the element, which contains what? The summation of the neutrons and the protons. Yeah, then they're saying the number of protons plus neutrons, that's the same as mass number. The number 4, the number of neutrons, no, that's force. The number of electrons, no, that's force. So the correct definition, or the other name for atomic number, is just proton number. So the answer here is number 2. Yeah, that's going to be the answer there. Then number 2, question number 2, they're saying isotopes are atoms that have the same dash but different. What's the correct answer here? Betha, what would be the answer here? What would be the answer here? Anyone? Christopher, what would be the answer here? Daniel, what do you think would be the correct answer here? Isotopes are atoms that have the same atomic numbers. Number three. Isotopes are atoms that have the same atomic numbers but different mass numbers. Yes, the correct answer here is 3. You can give an illustration. You can even give an example of what. You can have chlorine 34, but there's still 17. You can have chlorine 37 and still 17. So the mass numbers are different, but the atomic number are simply the same. So that's okay. That's the answer here is 3. That's the best option. Okay. Then the next one there, they're saying the element which has the mass number 12 and the atomic number 6 is. So here you just refer to your periodic table. This is carbon. The correct answer here is carbon. Hope this is okay. Then number 4. So we should just run through this, guys. Shouldn't take us a lot of time. Then number 4, they are saying the region of an atom which can be filled with 1 or 2 electrons is known as what? What's the correct answer here on number 4? It's 4. Yes, at an atomic orbital, not a shell, because orbitals are found on shells. So the correct answer here is an atomic orbital. Yeah, so 1 or 2. This is a typical illustration here is like 1s, right? Or 2s. That's an orbital. So this is what we have, because if it was a shell, shells are not limited. They are limited, but we could have the first shell has 2 electrons, but the second shell can accommodate how many electrons? 8. Yeah, so this is only limited to orbitals. Orbitals, S in particular, can only have 2 electrons. So the answer here is 4. That's the best option. Then number 5. We are here on number 5. So 5, we're just saying for the second shell of an atom to be stable, it must have, for the second shell, so read the question more than once for you to not make a mistake. They're saying for the second shell of an atom to be stable, it must have electrons. How many electrons? 8 electrons, isn't it? It's a shell, so the second shell can only be fully stable and has 8 electrons. Yeah, so the correct answer here is 4. Then how about number 6? They are saying which of the following substances has a polar covalent bond between its atoms? We can disqualify 1 because sodium chloride has ionic bonds, right? So 1 is disqualified because this is a metal and a non-metal, so it doesn't qualify to have it is polar, but the part for the covalent bond does not agree with what sodium chloride is. Then 2, they are saying hydrogen molecule. It is a covalent bond, but the part for polar does not agree because hydrogen to hydrogen, the electronegativity difference is going to be 0. So this does not support it being polar. Then the glucose molecule, glucose to some extent is not soluble in water, so we cannot conclude to say this is it has covalent bonds throughout, but it's not relatively polar. Then methyl group, this is an alkyl group. Alkyl groups are relatively radicals, so they're radicals because they're just missing 1 hydrogen, or they're just missing 1 electron for them to be happy. So the correct answer here is 5. this is a double bond. So in case you're wondering how is it a polar covalent, because oxygen to oxygen form a double bond. These guys form a double bond like this, and they have lone pairs here. This is very reactive because it shows that these guys are lacking extra electrons. So we discussed under chemistry to say a triple bond is more reactive than a double bond is more reactive than a single bond. So by virtue of it having a double bond, and you know what oxygen is very electronegative. So this is going to create this molecule to be polar. So the best option here would be 5. That's our best option here. Yeah, so the oxygen molecule. Is that okay, guys? Any questions here? Then number 7, what's the best option? Number 7, they're saying which of the following substances contain an ionic bond? This should be just sodium chloride. Why? Because you know what the definition of an ionic bond is, metal and a non-metal. So these should be just free marks if you see such. Then number 8, which of the following is true about the type of bonds in liquid water? So when water is in liquid form, which of the following is true, right? About the type of bonds in liquid water. So we can start to disqualify the answers. The first one, water contains ionic and non-polar hydrogen bonds. Already, because of the ionic part, we disqualify this guy because water doesn't have ionic bonds, because water is what? Water is a covalent molecule. So number 1 is already disqualified. Then number 2, they're saying contains hydrogen bonds only. That's false. The reason why this is false is because in water we have what? We have hydrogen bonds. We have the first one is covalent bonds. Covalent bonds followed by hydrogen bonds. Hydrogen bonds will create, we can have cohesion and adhesion forces, then that will create surface tension. So that's the order. So 3, water contains both polar covalent and hydrogen bonds. So 3 is correct. Then number 4, water contains non-polar. That's false because water is a polar molecule. No wonder it's a universal solvent because it has dipoles. Then number 5, water contains both non-polar. So the non-polar part disqualifies number 5. So the correct answer here is 3. That's what you have. Then number 9, I'll choose to skip this guy because you have not yet learned how a DNA and an RNA structure looks like. This is under nucleic acids. Yeah, so I'll just skip number 9 to focus on what you already know. Then look at number 10, or the coverage of your test. Number 10, guys, what's the order in the decreasing strength of these bonds that are given here? What is the best answer here? What's the order? Qualify them. So we talk about the order of what they're saying in the order of decreasing. So decreasing meaning the one that we have first must be the strongest, right? Yeah, so look at number 5. Number 5 is already disqualified because van der Waals are the weakest. So this is disqualified. Daniel, you were saying should be what? Number 3, why 3? I was saying 3. So covalent is the strongest, yes. Then how about the strength in between ionic and hydrogen bonds? How do you explain it? Daniel, why 3? So you are explaining to say the order is simply going to be So the correct answer here should be the first one is ionic. Yeah, so ionic then followed by covalent. So we're saying we have, this is going to be what? This is covalent bonds. Covalent bonds are stronger than hydrogen bonds. Yeah, so ionic should be the ionic, then followed by, let's see the order between hydrogen bonds and covalent. So Daniel, you are saying 3. Mapalo, what do you think? Christopher, what do you think is the correct order here? Number 3, Christopher. Yes. Yeah, in the correct order, the normal order for these guys here, the bonds here, according to what is in the notes or how this is supposed to be in terms of the strength, ionic comes first. Yeah, so ionic comes first, followed by covalent. That's the order. Then from covalent, we go to hydrogen bonds. Then hydrogen, that's when we have van der Waals. Yeah, so the only thing that is close, we can just try to go to the nearest, the closest answer. So the closest answer here is going to be, so hydrogen and van der Waals are at the end. So there should be hydrogen, then van der Waals. So the best option here is we go for 3 because we are seeing there's hydrogen and van der Waals. Yeah, so they've switched covalent ionic because it differs. It varies depending on the molecule. So this sometimes can be controversial a bit. So the correct answer here is 3. That's the best nearest answer to the correct one. Or covalent comes first. No, here, no, to some extent he's actually right in that the main reason why we would suggest that covalent comes first is because in ionic bonding, the atoms or the elements are not linked to each other. They're only attracted to each other. For example, you have sodium ion and you have chlorine negative. These guys are attracted to each other because of the differences in the charges. Because sodium lost an electron, which chlorine attracted, and it became negative, while sodium became positive. So they're not entangled. But then comparing it with a covalent bond, covalent, they actually link together. They have to be sharing, so the orbitals are even entangled together like this. Yeah, so for you to split or to break down a covalent bond, there's this part in thermochemistry when you talk about bond formation and bond breaking. Yeah, so bond breaking needs a lot of energy, while bond formation releases energy. Yeah, so it's the chemistry behind this would suggest that covalent comes first because of how close the proximity in a covalent bond is. So intense, you cannot even dispute it because these guys have to come closer to each other. The orbitals literally have to entangle like this. Yeah, so it's just right that we can actually assume, though if you search on Google, they'll give you this order. So if you check on AI or Google, they'll give you this. This is the normal, but the conventional one is that covalent comes first, followed by ionic, then hydrogen, then you have van der Waals this side. Yeah, so hope that's okay. That settles the dispute. Then how about number 11? What's the correct answer here on number 11? Number 11, they're saying compared to the charge and mass of a proton, an electron has. So according to your chemistry, you learn to say the mass of an electron. So you have this from your chem. You know to say the mass of an electron under atomic structure is, you are saying what, 9.109 times 10 to the power negative 31 kilograms. This is the 31. Yeah, this is 31 kg. Then the mass of a proton is what, 1.67 times 10 to the power negative 27, yeah, kg. So you notice that the mass of a proton is more, the mass of an electron is less. So the correct answer here, they are saying compared to the charge and mass of a proton, an electron has an opposite charge and a smaller mass. Yeah, so the correct answer here is 3. The correct answer here will be 3. Hope this is okay, guys. Is this okay? Any questions here? Betha, is this okay? So the answer here is 3 as well. Then they're saying number 12. Which of the following are isotopes? So the definition of an isotope is what? Atoms of the same element, right? So the correct answer here will be 2. 2 is the only correct. Don't even try to calculate to confuse yourself, even if they've said carbon 14 and nitrogen 14. So even if they say what, chlorine 35 and sulfur 32, you may calculate the protons to be the same and the neutrons to be different, but because of our definition, the only suitable solution here is 2, because they have to be of the same element, atoms of the same element. So this is going to be giving us 2. So 2 is the best option here on number 12. Then number 13. What's the answer here, guys, to number 13? This guy here. What will be our option? It's 3. They're saying the electrons involved in chemical reactions are always found in the outermost shell. Because the first shell, no, those are core electrons. They do not participate in the chemical reaction. Nucleus, no, they don't. 2p, not all the time. Some electrons are valence electrons in 3s, 3p, and above. So the correct answer here is 3 in the outermost shell. Then you have number 14. Number 14, they are saying when oxygen is involved in a chemical reaction, what's the correct answer here? Before I give us the answer, when oxygen is involved in a chemical reaction, it's what? What's the correct answer here? What's the correct answer here, guys? What happens? Because here, okay, so atomic number is what? The number of protons, right? So when we say, okay, so they're saying when oxygen is involved in a chemical reaction, let's disqualify them. So number 4 is wrong because they're saying neutrons are involved in the chemical reaction. That's false. Anything that has atomic number is proton number. So the correct answer here is 5. Atomic number remains the same. Atomic number is the number of protons. So meaning the number of protons, the question they're simply asking here is, does the number of protons get to be, does it change? Right? So here it doesn't change. Proton number or atomic number is the same. It remains the same. The only thing that gets affected when oxygen is reacting is simply the number of electrons. Yeah, not atomic number, because atomic number means the same thing as proton number. It was just a catch. Yeah, so the correct answer here will be 5. It remains the same. Is this okay? Betha, you've seen the mistake here, right? Then we can talk about number 15. What will be the correct answer on number 15? They're saying an ion with 15 protons, 16 neutrons, and a charge of -3 has an atomic number of what? Again, they're just trying to see if you're following. Atomic number is the same as the number of protons. Does it get affected when something becomes an ion? No, it doesn't. So the correct answer here is still what? 15. So the answer here will still be 2. The only thing that gets to change is simply electrons, and they've become what here? 18, because this thing gained. It had 15, now it has a -3 charge, so now it has what? Gained 3 more electrons, so now it has what? 18. Yeah, so the correct answer here is still 2, that's still 15. Hope this is okay. What's the answer on number 16? What's the answer, guys, here on number 16? It's 2. The maximum number of electrons that can occupy the first shell. Yeah, so the first shell is 2. That's what you have. Then number 17, they're saying the orbitals of the second shell of an atom is what? What's the answer for number 17? So number 17, they're saying the second shell. So look at the configurations that you always write. The configurations that we always come up with is what? 1s2, then you have 2s2, then you have 2p, 2p6, but then for 2p, we know this is the same as 2px because there are 3 of them, 2py, then you can have 2pz. So in the second shell, you just have 2s, then you have these p orbitals. So the correct answer here should be 4. So 4 is the answer to number 17. These are all the orbitals you find in the second shell. Is this okay, guys? Anyone who is lost? Chris, is this okay? So we just have to exhaust all the orbitals. So that's what we have. Then number 18, which of the statements here, guys, is correct? They're saying choose the statement which is correct. Number 1, they are saying the carbon dioxide molecule has 2 covalent single bonds. Is this true or false? In a carbon dioxide molecule, guys. Look at a carbon dioxide molecule here. Let me show you. Carbon dioxide, you've done Lewis structures from chem. This is carbon dioxide. Carbon dioxide has 4 electrons in the outermost shell. Each oxygen has what? 6. This is going to give us 4 plus 12. This gives you what? 16. So we have to distribute the 16 electrons, and by the time you are done, carbon dioxide will have double bonds. No wonder the bond angle of carbon dioxide, if you check the schema table I once sent in the WhatsApp group, the bond angle is simply 180 because on carbon there are no lone pairs and it's a linear structure, right? Because it has double bonds. So the first answer here is false. When they say single bond, they just mean that carbon was interacting with each oxygen 1-1 like this. This is what they mean. This is false because each oxygen needs to form 2 covalent bonds. Yeah, so to distribute all the 16 electrons, this is 8, this is 8, to account for all the 16 electrons. So here, 1 is false. Then number 2, they're saying in the formation of carbon dioxide, electrons are donated by carbon to oxygen. That's not true. Being donated means ionic bonding. This is equal sharing of electrons. There's no atom that is donating. They are all sharing. So 2 is false as well. Then number 3, the water molecule has 2 covalent single bonds. This is true. So this is true because water, you already learned to say water has a what? Has a V shape, or rather it's bent. Water is like this. These are single covalent bond. You're seeing that. Of course, there are lone pairs there, but these are single bonds. So number 3 is correct. Then number 4, in the formation of water, electrons are donated. The disqualification here is on the word donated. So this is not true. So the correct answer here is just 3. Yeah, so 1 is not true. This was just a temptation for you to pick 5 because you'd have thought 1 and 3 are both correct. But the only correct answer here is 3. Yeah, when it comes to the bonds, there are double bonds in carbon dioxide. So that's the answer to number 18. Yeah, so we can go to the other guy, the next page, which is number 19. So number 19, they're saying choose the property which makes water an effective solvent. So what makes water to be an effective solvent? What's the correct answer here, guys? Quickly. 3. An effective solvent. Yeah, the dipolar nature. Yes, it has the positive and the negative. It can accommodate anything. Then how about number 20? Ice is able to float on liquid water because, what's the correct answer here? Number 20, guys, what's the correct answer? Why is ice able to float on water, guys? Let's number one. So the density, yes. The density of liquid water below the ice surface increases. The density of water in liquid form is high as compared to the density of water in what? In ice form. This is because in ice form there are no spaces in the water in the whole thing of ice. So in terms of spaces, we just mean if water is in liquid form, so water in liquid form has spaces in between. So they're like my spaces in between. These are spaces here. These are spaces. But when it's in liquid form, remember the definition of what? Of solid. When it's in ice form, the definition of what solid is anything that has a fixed shape and a fixed volume. It means there are minimal vibrations between the molecules in ice form because there are no spaces. They were squeezed. It's like compressed. Yeah, so the density reduces. Yeah, because the vibrations are minimal. We have what? Fixed particles. The guys are fixed. Yeah, in what? In ice form. So that's what we have. There are no spaces in between. Yeah, unlike when it compares to liquid. No wonder we say liquid, no fixed shape. It takes what? The shape of the container, right? Because it's moving up and about. The vibrations in liquid form are more as compared to the vibrations in solid form. So that's basically what we have. Yeah, so the correct answer here is 5. All these other explanations are really false because number 3, insoluble in water, no, it eventually dissolves, of course. Then high surface tension, no, that's only explainable if it was in terms of insects. Yeah, so number 21, what's the answer to number 21? Yes, so the correct answer here is 3, the cooling effect of vaporization. So it's like the example we did when we were looking at water. If you see the reason why footballers are given jerseys or sweaters after they are from the pitch is because they were running, they were sweating. The sweat is evaporating off their skin. It produces cooling effect. They'll feel a bit of some chilledness. So to counter that, no wonder they have to put on something warm. So this is the effect of heat vaporization. It takes so much heat for water to evaporate, but once it does, it causes the surroundings to cool off. It's the same thing that happens even in the evening. In the evenings, water in ponds or in water bodies is very cold. Why? Because the heat is being lost to the surrounding. During the day, the surrounding is giving heat to the to the pond, so it's warm. Yeah, so you have that. Then number 22, what's the basic reason, the best explanation why certain insects can walk on water? What's the answer here, guys, for number 22? What's the answer? It's what? So 1 is the best explanation. Why? Because in case you are tempted to think of 3 and also 5, this is false because they are partially true. Like number 5, they are saying the strong effect of adhesion. Adhesion should be against something, right? Then even cohesion, when they say the strong effect of cohesion at the water. So the working together of cohesion forces and adhesion forces produce surface tension. That's the best explanation to why some insects are able to walk on water. So that's what you have here. Yeah, so that leaves us to, we are here, we said we'll do 1 to 20. We have reached up to 22, so we are done with the first 20 questions from the first paper. Let's go to the next one. So this is just to clear and remind you of all the atomic theory that you learned. Yeah, so because the last time I was not fully prepared. I was using the form, so our discussion was not as fruitful as I wanted it to be. So no wonder I've decided to redo this guy. Quickly, guys, here, let's not waste time. What's the correct answer on number 1? Identify the false statement here. Which one is false? Which statement here is way false? The correct answer here is 4. I mean the false statement. The answer to our question here is 4. There are 3s orbitals in the third energy shell. That's false because you just have one 3s. Yeah, so the false one here is number 4. Hope that's okay with everyone. Yeah, we're looking for the false statement here, so it's number 4. The rest are okay. Then look at number 2. The valence of electrons of representative elements are. What's the correct answer here, guys, on number 2? It's 5. Let's see. We're saying the valence electrons of representative elements are in the s orbitals only. That's false. Located in the outermost orbital. Okay, no. Yeah, is it 2? The valence electrons. So when you then we say what? Located closest to the nucleus, that's false. Then 4, located in the outermost shell. We're talking about valence electrons, right? Located in the innermost. So which one is true between 2 and 4? Which one is more correct between 2 and 4? Mapalo, which one do you think is the answer here? Yeah. According to the definition of valence numbers, this is supposed to be 4. Valence electrons, right? These are found in the outermost shell. That's what you have. Yeah, so the correct answer here will just be 4. Then how about number 3? Number 3, what's the false statement here? Which statement here is false, guys? Which statement here is false, Betha? Which statement here? Or number 3? Mapalo, guys, what's the best try here that we can have? Number 1, we just decide to disqualify them. Okay. Okay, so Y1, so let's see. So they're saying the false statement, right? They're saying for the hydrogen atom, the energy of the 2s orbital is lower than the 2p atomic orbital. Then number 2, they're saying so let's start with the 5. Option 5, they're saying an atom with more than 2 electrons must use higher energy orbitals. Then so they're saying identify the statement that is not correct. That's what they're saying. Then here they're saying for an atom, the 3 2p atomic orbitals are degenerate. Then here they're saying for an oxygen atom, the energy of 1s atomic is lower than. That's true. Then for a carbon atom, the energies of 2s and 2p are different. So then they're saying for a hydrogen atom, the energy of the 2s orbital is lower than the 2p. So the one that's false is 1 here. It's correct, Betha, because for hydrogen, we don't even go as far as 2s. For hydrogen, we just have 1s. That's the configuration of hydrogen. Yeah, so the statement which is not correct here is 1. Yeah, so 1 is the one that we have something against. So that's the only ideal false statement there. Hope everyone is okay with this. Yeah, so you have to really be able to criticize the other options to disqualify them. So yeah, that's what we have. So 1 will be the best option. Then number 4, they're saying the lone pair of electrons in water are in. So where are the lone pair of electrons in water? Where are they found? So you just draw the molecule. You know how water is formed. Water is formed between 2 oxygen. 1 oxygen and 2 hydrogens. Now you know each oxygen has the following configuration. This is what you have: 2p. This has to be 6, so this is going to be what? This is a 4, is it? Then each hydrogen only has 1. So in the 2p, you see that this is what? In the 2p, you fill it with this. These are the electrons you fill. The 4 electrons. Then hydrogen, there are 2 of them, right? There are 2 of them. So because this is what this is in water. So each one is going to contribute. There should be a 1 here. Yeah, so each one, there's a 1 here. It contributes 1 electron there and also 1 electron there. So meaning the lone electrons are both going to be found in the what? In the 2s and in the 1s. So let's see if there's anything close to that. So they should be in the 1s and in the 2s. So the correct answer here is 3. Those are the electrons that are not participating in the bonding. Yeah, so the lone electrons, the 2 lone electrons, the 2 electron pairs that you see on top here, these guys here, yeah, they're coming from the 1s because these are the non-bonding electrons. Yeah, so the answer there is 3. That's the correct answer. Then how about this one here, guys? Phosphorus has an atomic number of 15, therefore the valence is what? Is everyone okay if we say 5? So 5, because just write the same high school configuration. It's going to be 285, so that's the valence. Then number 6, an atom of sodium with an atomic number of 11 and a mass number of 23 has, so it's going to be 3. We just say we have the number of protons and number of electrons is the same, 11, 11. The number of neutrons, you just subtract 23 minus 11. So you get your what? You get your 12. Then number 7, the third shell with 9 orbitals can hold up to, the answer is 18. So orbital slots, each of them can hold up to 2 electrons. So we just multiply 9 by 2, right? Because each orbital can only accommodate 2, right? Each slot. So 9 by 2, that's how we get the 18. Hope that's okay as well. Yeah, so number 8, the character of p orbitals which determine the character of atom is. So the answer here is directional, because p orbitals can either be found on the x, y, or z plane. So meaning the direction matters. Yeah, that's what gives these particular p orbitals the ability for them to determine the character of an atom. Yeah, depending on where. So this comes in on hybridization, guys. For you to relate this, you have to think about your chemistry as well. We said p orbitals can either be found like this or they can be standing like that. So when they are laying down like this, they can either create a sigma bond, but if they are like this, they can create what? A pi bond. Yeah, so it really matters the direction that these guys are laying. So you can have something like this. They can either be on the x-axis or on the z or on the y, depending on what your orientation in 3 dimension is, because these are going to constantly be rotating. You can't always say this is always going to be your x or this is your y or your z. They are constantly rotating, so the direction will just vary depending on the element that you're dealing with. So the answer here is A. Then number 9, an atom with 5 protons, 6 neutrons, and a charge of 3 plus has atomic number what? What's the answer here, guys? What's atomic number going to be? Atomic number is proton number, so the answer is 25. They're just trying to see if you're able to notice the difference. The wording is just atomic. The key is atomic number. So it's 25. The answer is 25. I mean, the answer is 1. There are 5 protons. Then here they're saying almost the entire mass of an atom is concentrated in the what? In the nucleus, right? Yeah, because that's where you find neutrons and what? And protons. So the correct answer here is 4. Then number 11, how many orbitals are completely filled with electrons in an atom of phosphorus in the ground state? So phosphorus has 15, right? So phosphorus has 15. You need to write the configuration. You can't guess. So this is what you have. 15, we're trying to distribute this. This is going to be that. 15, so that's going to be that. That's going to be 3p. Then that's going to be what? A 3. So you notice the 3 slots here are filled. The 3 slots here on P are filled. And then here you have that. Here, the 3 slots are only filled 1, 1. Here they are filled. This is filled. This is filled. Yeah, so this is what you have. This is filled. So how many orbitals are completely filled? There's 1, 2, 3, 4, 5, 6. So the correct answer to this thing is what? 6. The answer is 1. Option 1 is the correct answer. So hope you've seen what we've done. How many orbitals are completely filled? Meaning that have pairs. They're all paired. The only best option there is 1. That's what we have. Then how about number 12, guys? What's the answer to number 12, Mapalo, Betha, John? John, are you seeing what we are discussing? Are you following here, John? What's the best answer here, guys? What's the best option here? Two. So Betha, you're saying 2. You're saying what? The total number of s electrons. What is the total number of s electrons? So we go back to the 17 is chlorine, right? So you write the configuration of chlorine. So chlorine 17. So you say 1s2, you say 2s2, you say 2p6, you say 3s2, you say 3p what? 5, right? How many electrons are in the s? Question number, this guy here, question number 12. We're on number 12. You thought to know which? You thought to know on which one better? Oh, okay. No, we're on number 12. Yeah, on the second thing on number 12. So here we're looking for s electrons. So the s electrons, just look at the s. How many electrons do you have? 2, 4, 6. So meaning the best option here is 5. Yeah. We have 6 electrons that are found in s orbitals when you are dealing with chlorine with 17 electrons. So the answer here is 5. That's what you have. Then let's have this guy here as our last guy for today, because it's almost 22. So how many orientation would a p orbital have in space? How many directions can a p orbital flip in space? What's the correct answer here, guys? The correct answer here is 3. Option 3. There are 3 of them, because a p orbital can either face in the x direction, in the y direction, or in the z direction. Yeah, so those are the only orientations, the directions that the p orbital can have in space. Okay, so we end here. You can just try question 14 to 20 and just send me your options, then I'll mark them through because I already have the answers. Yeah, so we end here for today. But 22 hours I'm starting the kinetics class for those who want to join, but it's a recording. I'm just recording in advance, but in case you want to join and learn, then you can, but it's okay. I'll upload the recording. I just want to utilize the fact that we have power. So thank you so much for your time. Unless if there are any questions,